Hello everyone, this is Mr. Boutros Asad and today we will talk about patterns. We will explore patterns like odd numbers, even numbers, and multiples of 2, 10, 5, and so on. Let's make discuss this statement. All odd numbers end with 1, 3, 5, 7, or 9. I know that odd numbers, that numbers that I cannot divide it into two equal groups, like 5, I cannot break it into two equal groups. It will be 3 and 2, not equal, 2 and 3, not two equal groups. So 5 is odd number. Let's think of any other numbers that I cannot divide into two equal groups, like 13. 13, I cannot make it into two equal groups. If I break it, it will be 6 and 7 or 7 and 6. And these two solutions, neither this or this has two equal groups. So 13 is odd number. If you look at 13, you will find that it ends with 3. Let's think of another number, 25. 25, I can make it into 12 and 13, but they are not equal. They this is an odd number. It ends with 5 and 5 is here. So I can make a statement says any number end with 1, 3, 5, 7, or 9 is an odd number, like 37, 49, 71. All these numbers are odd numbers. Another statement here says all even numbers end in 0, 2, 4, 6, or 8. Remember that even number, a number that I can make it into two equal groups, like 6. 6, I can break it into 3 and 3, and both of them are equal to each other. So 6 is even number. Think of a greater number like 28. 28, I can break it into 14 and 14, and they are equal. So this is an even number. So I can make a statement says that all even numbers end in 0, 2, 4, 6, or 8, because 28 end with 8, and I can break it into two equal parts. 20 end in 0, I can break it into 10 and 10, so this is even number. So put in mind that any number end with 0, 2, 4, 6, or 8 is called an even number. Let's revise the word multiple. What the word multiple refers to? The word multiple refers to a product of two numbers, like 3 multiplied by 2 equals 6. 6 is called product. This product, I call it a multiple of a number. So I can say that 6 is a multiple of 2, and in the same time is a multiple of 3. So when I say a multiple of 2, so this multiple comes from repeating to a certain number of times. So all multiples of 2 are even numbers. Let's check this statement. Tell me any number of any multiple of 2. For example, 14 as a multiple of 2 because it is 7 multiplied by 2. Uh, 28, for example, it is a multiple of 2 because it is 14 multiplied by 2. All these multiples, or many other multiples, are even numbers because they end in even numbers. And if you check the list so long, you will find that all of them are even numbers. Because they are multiplied by 2, this means I can break them into two equal parts, so they are even. So all multiples of 2 are even numbers. Let's check this. I have these three lists. This list is about multiples of 2, 2, 4, 6, 8, 10, 12, and so on. Multiples of 5, 5, 10, 15, 20, and so on. Multiples of 10, 10, 20, 30, and the list goes on. So What I can say about these lists of number? Can I make a statement and this statement is true? Think, look at this list. I can see here 10. And here in multiples of 5, I can see 10. And also multiples of 10, here also is 10. So 10 here and here and here. So the number 10 is exist in the three groups, multiples of 2, multiples of 5, multiples of 10. What I can say about this? I can say that 10 is exist in the multiples of 2 and 5 and 10. If I extend the list, if I complete the list, I will find that 20 here is also 20 here, 20 here. And 20, I can make it by doubling 10. If I complete the list, I have 30, 30, 30. 30 also exists in the list of these multiples. So what I can say? I can say that any multiple of 10, any multiple of 10 is a multiple of 2 and 5. So if I complete, I can say that 40 is also a multiple of 2 and 5 because it comes from 10, because it is a multiple of 10. 40 and 50 and 60 and 70 and so on. All of them are multiples of 2 and 5 because they are multiples of 10. Why I can say this? Because 10 itself is a multiple of 2 and 5. So any multiple of 10 is a multiple of 2 and 5. I have another two lists here, multiples of 3 and multiples of 4. I have these two lists, 3, 6, 9, 12, 15, and so on, 4, 8, 12, 16, 20, 24, and so on. Which numbers appears in both lists? Let's check. Here I can see 12, and here also I can see 12. So 12 appears in both lists. So I can say that 12 itself is a multiple of 3 and a multiple of 4 in the same time. So any number comes from 12, or any number, a multiple of 12, is a multiple of 3 and a multiple of 4. Let's check. If I double the 12, it will be 24. Let's check. 24, yeah, it is here in multiples of 3 and multiples of 4. Add another 12, 36. 36 is here, multiples of 3 and multiples of 4. And if I extend or complete the list, it will be 48. 48 is also a multiple of 3 and multiple of 4. Why? Because it is a multiple of 12. So today we talked about patterns and how can we make general statement about patterns. This was all for today. Thank you very much.